well. If for some reason you can't make the session and you need to do it and you need to catch up, you can watch the recording. If there's something you want to go back and check and see what was said, you can do that through the recording. Remember, we can't see you, and at the moment we can't, obviously you can't unmute yourself, so you won't be seen on the recording, and the chat doesn't go into the recording. So this is me, Ken Beer, Principal Engineer at Safe System Solutions, and before that was worked for the Victorian Road Authority, Vic Roads. There's a little QR code for my LinkedIn if you want to connect with me, and I do like to continue the discussions in road safety infrastructure, and it's a good platform to do that. It's also a nice way to keep your address book automatically updated. So if you lose people's contact details, you can always contact them. So I don't think I need to tell you how to use a QR code, because we basically have to do that anytime we go into a restaurant these days or the like. But yeah, hover your camera over that if you'd like. Now, my contact details are there, and my role for this course is sort of twofold. One is that I'm the course moderator or MC or whatever you'd like to call it. So I'll be handling things behind the scenes, and I'll be looking at all the questions and comments that come in and feeding those to the technical experts, Jamie and Evan. But I also do delve into some of the technical stuff, so I'll run a few of the short sessions on a couple of the specific procedures or road users or the like. But we'll get to that. But there's my contact details. So if anything goes wrong, or you can't understand an assignment, or you can't find the quiz, or you can't access Moodle or the like, get in contact with me and I'll help you. I'll help you through it. There you go. I'll summarize there. There's a couple of extra bits of information here. How do you interact in this course? Well, there's a few ways to do that. We do like the use of the chat function. That's a good one, and you should have that available to you there. And you can simply chat there. You can chat to either all panelists, which will be Jamie and myself, or Evan and myself on Thursday, or you can select to talk to everybody. So if you've got a comment for the whole group, you can just use that drop down and make the comment to everybody. There's also the Q&A available, which is here. In case for some reason the chat's not working, you could use that, and we monitor that as well. If you do want to talk, if you want to delve into something a bit deeper, or tell a situation that you've got or the like, all you need to do is raise your hand, and we'll find you. And we don't actually unmute you. We just give you the ability to unmute yourself, and then you can unmute and talk. So that's certainly something that we like. In some of our later sessions, we'll do some live case studies and the like, and hopefully they'll be ones that you give us to have a look at with the group. And especially if we're doing that and it's your case study, we love having you there to talk through some of the background or the situations. Few backups if the technology fails, as it can do. You should have a memory stick, a little pack arrived, hopefully, maybe. And it has a memory stick with all the slides on it, and you could phone in and listen and look through those slides. That would be one option for you. You could text me if you're having trouble, and also on Moodle, which is the learning management system, you have access to all the slides as well, so you can have a look through there. We've got the three of us presenting. So myself, I've already introduced myself. Evan Coulson in the middle there. So Evan will be in on Thursday to talk about a variety of things. Evan is from the Department of Transport in Victoria, but also sits on ASBAP, the Off-Road Safety Barrier Assessment Panel. Yes, we've got him talking about a few different specific topics. And on the left of screen there, and you can see him there in Hamilton, Jamie Robinson, who's the technical lead at Safe System Solutions with me. And also, just like me, worked at the Road Authority, Vic Roads, for quite a number of years in different areas, was the technical lead there for traffic engineering and design for quite a while as well. So, and a huge amount of experience in the design and auditing and review of road safety barriers and dealing with the those really technical end challenges that we face out there. So welcome, Jamie, and we'll hear a lot from you soon. Moodle is our learning management system for this course. So hopefully you have seen the links have come in your email and the information. And this is the place you go to do your quizzes, your quizzes that happen at the end of each module. This is where you upload your assignment, where you can get all the different information that we've provided. We try to do this with the memory stick as well, so you've got that secondary option. If you really struggle with it, if you can't log in for some reason or the like, get in contact with me. But also, you do have that backup ability to email me an assignment if that failed. So yeah, keep in contact and get in there in Moodle. Thank you for those who have done a little introduction. That's lovely to see. It's hard to get that networking between participants of a course like this when we're all in different spots, but that's a nice way to see who else is on the course and what their background is, and you can even communicate with them that way. So a few of you have done the road safety audit course or the safe system assessment course with us online in this social distance education way of delivering things. So you're very familiar with Wally the Wombat, but others who are not familiar, this is Wally the Wombat, the warning sign. And Wally appears a number of times during each module on the slides. So you've got to keep your eyes peeled for Wally and count how many times Wally appears on the slides. And that is going to be one of your 10 questions in the quiz at the end of the module. Now, we do give you a little bit of tolerance either side in case, I don't know, you spilt your coffee in your lap and you Mr. Wally, you're probably still going to get the mark on that one, but it does mean you've got to be paying attention and watching what we're doing there. So you're on 0 Wallies. Your Wally count is 0 at the moment. That is just a demonstration Wally, but Wally could appear any times, be a bit smaller than that, and in the slide somewhere. We also like to give out prizes. So if you answer questions that I ask and you're the first one to get the correct answer, as in first one to type it into the chat or the Q&A, also little other spot prizes here and there for your engagement in terms of asking really great questions or being interactive. We have little spot prizes. Now, how do you get those prizes? Well, when you successfully complete the course, you are emailed a copy of your certificate, but you're also sent a hard copy of your certificate. And in that pack, if you've collected any prizes along the way, they'll be in there with the certificate. And I said they successfully completed the course. We actually have a benchmark requirement here for successfully completing this course. This is not one of the ones where you can just sit back and go through it and not actually have to do anything. We require you to attend 3 of the 4 live webinars, and you can then go to one of them and watch the recording at some later stage. We would love you to attend all 4 and ask questions in the chat and even put up your hand and the like, but we understand there's lots going on in people's lives. And if for some reason, it's absolutely unavoidable that you need to miss more than that one, get in contact with me and we can have a chat about We need you to complete all the tasks that we have required, and we need you to get an average of 80% for all the quizzes and the assignments. Now, don't get too scared about that because you have 3 attempts on each of them, and my mission is to ensure that you all pass. So if you have that first attempt and don't do so well, this is where I want you to get in contact with me, and we'll do some one-on-one coaching, or we'll revisit the material and I'll talk you through it again, and you know, we'll make sure you understand that, so when you get to those questions in the quiz or in your assignment, you're able to do it having that knowledge. So that's the logistics of the course. I'm going to pause there and see if anybody wants to type in a question or put up their hand, understand how things are going to work. So for this course, there is no site visit, unlike the Safe System Assessment or Road Safety Audit course, where we would send you out to a site near your house that we had prepared for you. This one is all done desktop. You do have a little assignment that you've got to do, but I dare say you won't find it hard and it won't take you long at all. So yeah, that's that. I'm just checking if there's any questions. Nothing's come in at this stage, but do feel free to use the chat to ask your questions. But otherwise, I might just do a little bit of scene setting before Jamie jumps into some of the specifics. We're talking about road safety barriers. Now, I mentioned earlier there, we're doing the fundamentals of road safety barriers here. So we want to get everybody on the same page with some of these sort of base level stuff. And some of you will probably know it, so it'll be a bit of a refresher on some of the things, but we will delve into some of the specifics and some of the challenges. We do offer a secondary course following on from this. We usually do these in 3 days in a row, but we obviously can't do that. But the follow-on course from this one, we do send you out to do a barrier design in a real world scenario and some extra stuff. So that's something that will be available in different jurisdictions as you know, restrictions allow, because that one can't. It's a little bit hard for us to do that via e-learning style platforms. But let me start with a bit of scene setting for you, and I'll do this fairly quickly. I'm going to use Victorian data here. The other jurisdictions, in terms of the numbers of people killed on the roads, vary, but across Australia, we're talking about somewhere in the order of 1,000 to 1,200 people killed on Australian roads every year. And if we look in Victoria, we're looking at somewhere around the 250, 260 mark every year of people killed on the roads. It's staggering. And when you then think about serious injuries on top of that, and these can be lifelong debilitating injuries, we're talking numbers almost 10 times that. So we've got a huge issue here to deal with. It's a major health issue that we are facing. And the challenge we've got is it's not a new issue the way COVID arrived, and the response to that was very big and quick and fast, and it was new and scary and the like. This one's sort of been with us, and it just continues to roll on year after year after year. So we need to continually try to push and challenge that. 2020, actually, prize for somebody. This can be a bit biased towards the Victorians, but anybody who can tell me the 2020 number of people killed on Victorian roads can win our first prize. Anybody who monitors the, so put that into the chat, and we'll see who gets that first. And yes, feel free to have some guesses, because I'm going to go with Jason. Oh, there we go. They're coming in. So Jason was first with the correct answer of 213. So interesting there, the 213 lowest on record for Victoria in terms of death and serious injury since those specific records were covered. And we just had 2020, the year of the pandemic, where we all basically didn't leave the house in Victoria. So we still had 213 people killed on the roads. Interestingly, the New Zealanders were analysing a bit of that, and they had quite a high number of people killed on their roads when they didn't let any tourists in. So all the people who used to blame the tourists as the reason for their high road trauma were sort of put back in their place. That was a pretty comprehensive study of that. I want to break this down a bit, and I'm still using Victoria, but actually this sort of data in terms of where things are happening at a percentage-wise is very similar across all jurisdictions really in Australia, except probably ACT and the Territory and Northern Territory, a little bit more skewed. But if you see here, we've got metro when we take fatal and serious injury crashes into account. We see that the metro areas are higher than the rural areas. But if we just look at the most severe end of those, and we're using the fatalities as the indicator of most severe there, it skews towards the rural areas. Now, I've got to write down who's getting prizes before I forget. But I'll give another little prize here for the first person that can write in why they think that it changes there when we go and look in the high-end severity and it goes to rural, but in the broader category of serious injuries and fatals, which is a bit of a spectrum there, it skews more to metro. Any thoughts on that? Oh, there we go. Wow. Okay, they're all coming in thick and fast, and they're good answers, and everybody's very much on the right track there. So the speed is really the answer. So Catherine in there on speed picked a specific crash type as well, which is interesting. But I'm going to give Catherine the prize there for speed. It really just comes down to the speeds that incidents happen, which increases the severity of those incidents. And then again, to break things down a little bit to give us an idea of, what sort of crashes are making these things up. If we look there at the fatal and serious injury again, intersection crashes quite high. They stand out there in terms of the number alone. Then we see fixed object or rollover and head-on crashes there. Now, there's a number of other crashes in here before we get to head-on overtaking, but I wanted to put head-on overtaking in there because that's a common misconception when we talk about head-on crashes in road safety, that people think that these are all those people who make bad judgment calls on their overtaking maneuver and head-on crash. Well, no, the overwhelming majority are people that have drifted out of their lane, maybe drifted out of their lane to the left and overcorrected and gone onto the wrong side of the road. So not intentional overtaking maneuvers that have gone wrong. Those do present a bit, but no, their head-on is big. Now, I tend to categorize these run-off road to the left, run-off road to the right, and head-on, combine them into what I call a lane departure crash. A lane departure, basically, someone's left their lane. So you can almost add that on top of that. And we see that even in, for fatal and serious across Victoria, it's getting up there as the dominant source of trauma in terms of crash type are lane departure crashes. And when you look at it at fatal, so again, an indicator of the severe end style, obviously that is the most severe, but then we've got these high level serious injuries as well. We're seeing that even the fixed object rollovers dominating with intersections, but then you could add the head on top of that, and you see it swamps. So really, this huge source of trauma, and the dominant source of trauma to Victorians in this case, but the same we're seeing across New South Wales, Queensland, Tassie, South Australia, are all these lane departure crashes, and the highest severity ones out in the rural areas and where the speeds are high. Just, I suppose, in a couple of minutes, I want to touch on how we perform against the rest of the world. It's a bit of interest for you, but an acknowledgement that we've done some pretty amazing things in road safety, and we shouldn't be just down in the dumps about our performance. We've done some pretty amazing stuff. Here we see the fatalities per head of population there, per registered vehicles, or per 100 million VKT. So first one in the chat to tell me what VKT stands for. You can have a prize as well. What a prize giving out prize. Wow, there it is. Joshua has got in there again. Vehicle kilometers traveled. It was quick. So vehicle kilometers traveled is really a measure of exposure. So like how much driving is actually happening, how much movement is happening out there. So for example, per head of population, something like the US will always argue, oh, that doesn't, you can't do it by that because we travel more than anybody else. So it should be done by VKT. Admittedly, they come into the numbers there, but they're not still performing that well, even by VKT. You see Australia's in there. Victoria performs very, very well in most of these. And then we've got the Scandinavian countries and the Europeans really leading the nation in all, leading the world in all of these. But this is just the top end of the world, really. If we take this and we just show a few of the worst end of the world, big South Africa, Iran, Thailand, Libya's, extremely bad, obviously. And there's probably a few hundred countries that could go into this sort of category that way. So we're dealing with a worldwide epidemic here. We've got 1.2 million people killed every year on the roads, and as I say, we think about 10 times that seriously injured, but nobody's keeping records in a lot of countries on that sort of stuff, which is a bit sad. So huge amount of possibility for us to do some pretty amazing things in terms of reducing that trauma and really concentrating on it. And as I said, one of the biggest sources of this trauma is when people leave the road and they hit trees, they hit power poles, they hit other things. The violence of this sort of crash, and when I talk about violence of the crash, I mean the energy transferred to the occupant of the vehicle. It is huge. This is what we would refer to as a point source hazard, a tree here. And so the energy transfer is concentrated, and the occupant of that vehicle is basically taking all of that energy in the form of deceleration in an extremely small amount of time. What we understand about the energies that the human body can handle in these sorts of crashes, where the vehicle is yawing, and that's so sliding side on its, and it hits a tree like this. If it's a hit like that on the driver's side, the driver is unlikely to survive this anything above about 40 kilometers per hour in the impact speed. It's pretty low in terms of the speed that we're traveling on a lot of our road network. We see the same with power poles, point source hazard, energy straight into the occupant of the vehicle. And the really scary, extra scary part of this is as a vehicle leaves the road and strikes a point source hazard, there is a slight tendency for the vehicle to wrap around it a bit and the occupants to find that rigid point source with their head. And so we see a lot of acquired brain injuries and some pretty horrific trauma in these point source hazard crashes. Head-on crashes can be done at a bit higher speed, and we get the energy transfer is a bit less. And that's because there are the crumple zones, the airbags, the seat belts. They're all designed to cater for the energy of that frontal collision. So what we know is that somewhere around the 70 kilometers per hour as the speed of each of these vehicles is what is generally survivable. Now, obviously, there's going to be cases either side, but that's a general sort of speed that we think about. We know when vehicles leave the road, even if there's nice, cleared, open spaces, we still see some trauma. Now, these aren't as severe as hitting that tree or that power pole, the point source hazards, but vehicles rolling over are showing us a degree of trauma, more in the spinal injuries, again, head injuries, but we do see fatalities as well in that. So even those cleared areas that we've provided for many years are still presenting us with some trauma in that sense. And we're seeing vehicles go beyond whatever we clear and finding point source hazards, trees, power poles. Even cuttings can snag vehicles, and those can be hazardous as well, be they people going up them and rolling over, snagging. So in terms of how we're going to deal with this huge trauma, it's no surprise to any of you, I don't think. Barriers are going to be a huge part of it. They're identified in many jurisdictions, in fact, all jurisdictions, road safety strategies are doing that. You see on the front cover of our just previously previous road safety strategy, a big barrier system on the Melbourne Highway. I took that photo while I was doing the post-opening audit of that one, actually. You can see there's a slightly different one on our newest road safety strategy in Victoria. There we go. We've got the New South Wales one, barriers. You know, there's no real surprise there, and other jurisdictions will see that. Barriers are going to play a huge role in us achieving some significant step downs in that trauma level that we're seeing. And what we want to do today is ensure that we know the best ways those barriers can go in to save as many lives and prevent as many serious injuries as we possibly can with that investment, and to talk a little bit about where it's best to put them and some of the challenges that we might face. And certainly we also want to make sure we're not creating new hazards when we put those barriers in, or if we have existing barriers, to be able to identify where they are hazardous. Good time to be taking this course because there's been a recent update to the Austroads Guide to Road Design Part 6, which is roadside design, safety and barriers. That's that document there. So Jamie's going to talk you through some of that. And another important document, and again, a great time to be doing this course, is that we've just, or we are just transitioning to MASH. And MASH is the Manual for Assessing Safety Hardware, the protocol for testing barriers to say, well, this one, you know, passes the test, so it can be used, and this one maybe doesn't, so, you know, it's not MASH. So you probably heard that term MASH, maybe, and a lot of chatter about transition to MASH, and is that MASH compliant? Well, MASH is Manual for Assessing Safety Hardware, and Evan's really going to talk in detail about that tomorrow, so you understand what are the barriers able to do, or what were they tested to do. And then when you're designing, maintaining, or the like a barrier system, you know how it's been tested and what its ability, you know, what abilities it has based on that test. And then if you're making decisions, design decisions in accordance with what it's, you know, what it's tested at, that is much better than just blindly seeing a number. And barriers are one of our most vivid, clear examples of safe system infrastructure. The reason for that, the safe system basically has these principles that says human bodies are vulnerable and we need to understand the forces on the human body and make decisions around that. We've got a shared responsibility, so now we can't just, we cannot blame drivers. We need to stand back, objectively look at our system and say, what can we change in the system to mean that doesn't result in death or serious injury? So if people fall asleep, we we want to say, what could we have done to mean that that didn't result in death or serious injury? We don't want people to fall asleep at the wheel, but they do it all the time. And we're going to continue to try to encourage them to get a night's rest and, provide rest areas and those sorts of things. But we need to acknowledge people will fall asleep, people will leave their lane for one reason or another. How do we make that not a death or a serious injury, but instead a property damage, and some maintenance work needs to go into the barrier or the like, whatever we've decided to do. Because people make mistakes. Essential to put yourself in the mindset of mistake making and say, we need to design to cater for mistakes because we're dealing with humans. We're designing a system for humans, and humans make mistakes all the time. Made lots of mistakes already today. None of them have resulted in death or serious injury, hopefully. And but that's, being human. We learn from our mistakes, but the lightning will strike randomly in terms of mistakes out on the road network, and some of them will result in death or serious injury. Barriers just do not care what the mistake was. They do their job and they dissipate energy along the barrier over time and provide a friendlier stop of the vehicle than hitting a pole, rolling over, hitting a culvert, or hitting another vehicle in a lot of situations, in most situations. But Jamie's going to talk about all of that in much more detail. Any questions for me on my sort of scene setting or the running of the course? All right, well, keep the questions or comments coming in, either through the Q&A or the chat. I'll monitor that behind the scenes. I may pop in randomly, Jamie, and ask a question or put up a poll or something, but we'll see how we're going on time. Over to you, Jamie.
Thanks, Ken, and good afternoon, everyone. So today is really about the role of safety barriers in addressing our road safety problem. In the next few sessions, we'll get into the ins and outs of the different systems and so on. But for now, I want to continue talking about what constitutes a hazard in the roadside and when does a barrier provide a benefit in shielding those hazards. And it really is a bit of a changing space. A lot of that change has come about with the update of the Austroads Guide to Road Design Part 6. It was released in August. It is the primary reference when it comes to designing safety barriers and assessing the risk of roadsides. Most of the change with the new version was in the early sections of the document, which are around risk assessment and hazard identification. And there is a new process detailed in that document. A couple of webinars were run by Austroads last year. They're still available at the Austroads website, and I would encourage you all to have a look at those. I will introduce you to that new process later in this presentation. So Part 6 is our primary reference. We also refer to the Austroads Guide to Road Safety Part 9. It is, however, quite outdated, and a new version of that is in the works. With the Guide to Road Design Part 6, most, if not all, of the states provide their own supplement to that document. Victoria has more specific guidance around barriers than any other state, which is sort of a good and a bad thing. Its supplements are typically quite lengthy, and VicRoads did preempt the release of the updated version and put out quite a lengthy supplement in 2019. So some of the information in that document is now, I guess, redundant because it's covered in the new guide. State-specific supplements do take precedence over the Austroads guide, so always refer to your relevant supplement. RMS in New South Wales has a fairly brief supplement. I note that RMS or Transport for New South Wales is yet to adopt the new Part 6 and has not updated its supplement. I expect that they will adopt that imminently and that the supplement will be updated accordingly. South Australia has a little supplement. We'll talk about the new risk assessment process that the guide includes shortly, and South Australia is a bit ahead of the game there in releasing some guidance around how to use that. What the new guide does do, I think, is provide some clarity around assessing roadside hazards. It categorises hazards based on a trauma index, and the new procedure for assessing roadside risk uses these trauma indices. The first category and the most severe category of hazards is referred to as significant hazards. These are the ones with the highest trauma index, a trauma index that is sort of equivalent, I suppose, to striking something like a tree in the roadside. Now, I will stress that these lists relate to the occupants of cars, of passenger vehicles. If you're riding a motorcycle, there are probably some more minor hazards that would be considered significant to that motorcycle rider. If you're in a heavy vehicle, perhaps some of these hazards are not so severe because of the greater protection and stiffer construction of heavy vehicles typically. So some of those significant hazards there, obviously trees and poles and the like, fixed rigid objects that if you were to strike them in your vehicle would bring you to an abrupt stop. There is some clarity around batters, cut and fill batters, in terms of the slope and the height of those batters that represents, in this case, a significant hazard. Vertical drops and watercourses more than 2 metres high or deep, and things like drainage structures, head walls and the like that, as I say, would bring you to an abrupt stop. So this is the most severe category of hazard. I don't think there are probably any surprises in there to you. So it's no coincidence that trees are at the top of that list. Trees are perhaps the biggest killer, for want of a better word, when it comes to run-off road crashes. Unfortunately, we see every week a vehicle departing the road and striking a tree. If the vehicle is to strike that tree side on, the chance of a death or serious injury is increased further. Some work by Newark in Victoria has I guess, quantified the likelihood of a serious injury resulting in a strike with an object. And that study has revealed that 87% of the time a serious crash has occurred where a roadside object has been struck. And most of the time that object is a tree or a pole. Most strikes with trees are in rural areas. Most serious injury and fatal crash strikes with trees are in rural environments. In urban environments, it's more likely that those serious crashes involve a pole, a utility pole. There is some guidance around when a tree is considered hazardous or non-frangible, and generally it's considered that if that tree has a trunk with a diameter of 100 millimetres or greater, I think measured at breast height, then it's considered non-frangible. And the same could be applied to any timber object in the roadside. Trees can be quite subjective to assess, however, and I like to show this photo because it really demonstrates the change in thinking that's happened in only a short period of time. This is a divided highway, trees in the median, typically of this type. I think they're melaleucas. At the time, about 8 or 9 years ago, a project was implemented to shield isolated hazards with safety barriers. This particular type of tree was considered frangible, and no safety barriers were installed at locations such as this one. Only a handful of years later, Another project came through and continuous barriers were installed at this location, recognising that regardless of whether the trees presented a risk, or they did present a risk, there are other risks present as well, perhaps rollover in the median, vehicles continuing onto the opposing carriageway, and beyond. Utility poles very much like a tree in terms of the risk that they present, and they really are often located in the worst positions when it comes to wanting to deal with them and address the safety risks that they present. And this photo demonstrates that. We have a row of poles adjacent to a high-speed road, lots of little access points dotted along. You can see an attempt has been made to shield many of those poles with some short lengths of barrier. Some remain unshielded in the foreground. I'm not sure why. Some have been shielded or protected, or an attempt has been made to protect them with some crash cushions. You can see these black Raptor crash cushions located about some of those poles, which are not something that we would like to see used in a high-speed environment. They certainly in the high-speed environments offer pretty limited protection and should be considered as a real last resort. But in this case, they've been applied because it's simply not possible to install a longitudinal barrier to shield those poles. Alternatives might be to relocate or underground the power, but as we all know, those solutions are extremely expensive and rarely happen. So in the case of poles, safety barriers are the popular treatment. This looks like a utility pole. It's actually a rigid light pole, which I'm not sure if it went in before or after that safety barrier, but I would argue that barrier being there actually increases the risk presented by that pole. The vehicle that struck that barrier prior to the pole would be directed towards it. We also couldn't be sure of how that barrier would perform if the vehicle struck the barrier and the pole at the same time. So it's best to keep any poles well clear of barriers to allow the system to perform freely. The preferable situation would be to have installed a frangible type pole and remove the hazard altogether.
Amy, how do frangible light poles go around barriers in terms of maybe within deflection zones or the like? Is there any information on that?
Yeah, certainly the preference, Ken, is to locate those poles outside deflection zones. There is an argument that they're frangible anyway, so why not install them within that deflection zone? The performance of a barrier in conjunction with a pole located within its deflection zone is just a bit of an unknown. We can't be sure how that combination of things would work, so it's best to err on the safe side and avoid any interaction whatsoever. Often we seek to minimise the deflection of the barrier by stiffening up post spacings, which allows us to locate poles or retain poles that are located close to the back of the barrier. But the best situation is to have any poles, frangible or otherwise, outside deflection zones. Cantilevers, sign supports and gantries are something that in the past have often been located outside clear zones, as was this one on the Hume Freeway near Melbourne. So the column of that sign support is probably in the order of 9 or 10 metres from the edge line or more. This road, as have all similar roads around Melbourne, has recently been treated with continuous barriers. Now, when we're dealing with hazards like cantilevers and gantries, as you can see here, there is a secondary risk that we're equally concerned about, and that is the potential for that structure to fall over onto the carriageway and result in further crashes and pile-ups and so on. So these type of features are typically afforded a higher level of containment, certainly higher than the wire rope barrier that you can see there. So going forward, certainly in Victoria, we would typically see a high containment level system, at least a test level 4, and we'll talk about test levels and that type of thing soon, and perhaps even a rigid system, a concrete system. But it is important to be mindful when we're assessing roadside hazards, mindful of the potential for secondary consequences. That might be a gantry falling over a carriageway. It might be a heavy vehicle, especially leaving the road and passing over the side of a bridge onto a roadway below or a railway line, or taking out a piece of critical infrastructure. And it's in those cases that we would typically look to beef up our containment level of barrier. We're more concerned about that secondary consequence than the single vehicle run-off road crash. There's a raft of drainage-related hazards that we find in our roadsides. Here you can see an end wall, a concrete head wall at a driveway culvert. That a vehicle that leaves the road in advance of that head wall is likely to be directed towards by the table drain. So this is not something that would typically be shielded with a barrier in its own right. Installing a drivable end wall would be an obvious solution there. Within a median here, we have a couple of head walls. One side, we have a safety barrier. On the left-hand side, we do not. We could install one there to offer protection to these head walls. We could perhaps pipe between them and backfill, put in a graded pit or something to certainly reduce the level of hazard that was present in that median. Structures like this are hazards that you want to identify very early on in your design process. They are particularly costly and time-consuming to address. Now, this one arguably doesn't meet our criteria for a significant hazard or warranting protection because it's not a great drop. This structure appears on a project that I was involved with, and it was shielded with a barrier. And because of the limited depth available over the structure, it required a structural design, a ground beam to span that structure, and a barrier with a bolt down post arrangement. So that was a very costly and time consuming process to make that happen. So I urge you to sort of prioritise things like structures if and when you come across them. There is some guidance around when fill batters are considered significant hazards or lesser hazards. And in general, an embankment or a fill batter that is relatively flat, say 6:1 or flatter, is not a hazard. It's considered recoverable, meaning that if you were to leave the road and were alert enough to steer back towards the road, you could do that. You could recover your vehicle back onto the road. The key change that I want to point out here is that slopes of steeper than 4:1 are now considered hazardous. Previous guidance classified slopes in the range of 3:1 to 4:1, meaning 3 horizontal to 1 vertical, being a 3:1 batter, or 4:1, as you can see here. So slopes in that range of 3:1 to 4:1 were previously considered traversable, meaning that you couldn't recover your vehicle back onto the road, but you could traverse them without rolling over, in theory. The change has come into the new guide that slopes any steeper than 4:1 are now considered non-traversable or hazardous. Now, there is a little bit of an inconsistency across the Austroads suite of guides around fill batters now, but I expect that other parts of the guide, such as part 3, will be updated accordingly soon. Cut batters really are quite a subjective thing to assess in terms of their risk. There is some vague guidance in the Austroads guides about what cut batter does present a hazard. Certainly it was more vague in the past. There is some better guidance now, but it really does come down to the surface of that cut batter. If the surface is fairly smooth, there's a school of thought that the cut batter will act like a rigid barrier and redirect that errant vehicle. On the other hand, if the face of the batter is rigid, it's likely to snag an errant vehicle and does present a significant hazard. Cut batters often appear in locations where we're really constrained for space. So the decision to install a barrier can be a complicated one. We often don't have the space to install that barrier at a desirable offset. There are often other features in play that complicate things. There might be a curb, and we'll talk a bit more about that shortly. So it really is a case-by-case situation. Where we do have cut batters, you often do find there's a table drain at the base of that batter, as you can see here. And where that is the case, there's a further increased risk because a vehicle that enters that table drain, depending on the slopes involved, may snag at the base of the table drain. So the Austroads Guide to Road Design Part 3 provides some combinations of foreslopes and back slopes, as they're called, that are considered non-hazardous or certainly are preferred. There's a cut batter with a rock face. It's certainly not smooth. It's somewhat jagged. There is a table drain at the base. It's not a location where you'd want to depart the road. But you can also see that it's on the inside of a curve. There's not much of a shoulder to work with there if you were to install a safety barrier. If a safety barrier went in there, it would likely obstruct sight lines to the pavement around that curve. It would limit the space available for someone to move off the roadway if they had to, or if they broke down there or had to stop in an emergency situation. So on balance, installing a barrier at this location would probably create more of a problem than it would solve. Further up the same road, we have another cut batter. It's a smoother face, so probably less hazardous, but again, there's not much room to play with. There's a curb as well, which really does limit our options in terms of where we would locate a barrier in relation to the road. It's on the inside of a curve again, and we know that the frequency of run-off road crashes is reduced on the inside of curves. So the likelihood of someone departing the road at that location is probably low. And again, installing a barrier here would not be a good idea unless we were to undertake significant widening. Cut batters can be deceiving. This is one that, and I really got to have a before photo, but it was a nice, smooth, grassed batter, but there'd been recent rain and it was really quite soft. and the impacting pickup truck there really did create a divot, and enough of a divot to cause that vehicle to flip and roll. So what may seem a relatively nice smooth and safe cut batter may not be. So certainly on our high-speed, high-volume roads, where we might consider installing continuous barriers, there is merit in continuing those barriers past cut batters. That certainly does present some challenges from a design point of view, and we'll talk about some of those things in future sessions. So the next category of hazards is referred to as less significant hazards. Again, primarily based on the severity of crashes involving the occupants of passenger vehicles. In this category, we've got things like frangible light poles, fill batters that are lower and flatter than those in the significant category, rocks and other objects that protrude above the ground, but not to an extent that they would cause that vehicle to stop abruptly, shallower watercourses, and so on. So these are ones that I suppose in general would be unlikely to result in death or serious injury, but certainly would result in property damage and perhaps some injury to the occupants of errant vehicles. Now, when considering any of these hazards, we really need to be mindful of likely impact speeds and angles with these hazards. In a low speed environment, probably a lot of the hazards that appeared in that significant hazard category are not hazards. So for instance, a tree or a pole very close to the roadway in a local 50 km/h environment would not be considered a significant hazard, and it certainly wouldn't be shielded with a barrier. But in a high speed environment, it certainly would be a significant hazard. An object like a drop-off at a bridge, regardless of speed environment, would be a significant hazard because of the potential severity of a vehicle dropping over the edge of that structure.
I mean, you mentioned there high speed, low speed environment. Where would you draw the line between a high speed and low speed environment?
Good question. High speed environments, 80 km/h or greater, is typically considered a high speed environment. 70 km/h really is the cusp, and we know that safe system, tolerable speeds under the safe system are in the order of 70 km/h for head-on crashes with other vehicles or roadside objects. But if we're in the realm of 80 km/h or above, we can expect to see some serious and fatal outcomes involving crashes with roadside objects, and that's where we really look to road safety barriers.
Okay. Now we're halfway through today's module, so I'm going to give everybody the opportunity to have a stretch, fill up their glass of water. So I'll give you 2 or 3 minutes to do that now, and then we'll get back into it. But do feel free to ask questions or comments or put your hand up as we tick along. So I'm going to give you 2.5 minutes. Okay, just while the others get themselves back, I'll just let you know that in our fourth module, so next Thursday it must be, is the opportunity for Jamie and myself to talk through any particular case studies that you might have. So if you're working on a design or you've got a particular hazard out there that you're trying to protect road users from, or different challenges that you've got, we encourage you to send through designs, photos, the location, so we can street view look at it. And we'll actually have a bit of a chat about that during the last part of that final session. So it's really a way to talk about some live examples as they're on the go. So have a think about anything that you've got, and yeah, feel free to send those through at any point over the next under 2 weeks we've got together. So it's an opportunity. All right, Jamie, I'll let you keep moving along, but please, everybody out there, pop in questions in the chat or the Q&A, and I'll feed them through to Jamie.
So we've just discussed this category of less significant hazards. There is I guess a third category, which is a subset of the less significant hazards group, which are referred to as minor hazards. So these are some less severe fill batters, shallow watercourses, and so on. And interestingly, the bottom sentence there is a direct quote from the guide, which states that impacts with even these minor hazards are more severe than impacts with safety barriers. That really is quite a shift from the previous edition of the guide, which made a point of encouraging practitioners to consider safety barriers as hazards in their own right, and it certainly can be the case that they are, but with the introduction of more flexible systems, the newer technologies that are around now, there's more learning and research. The evidence is overwhelming that a flexible safety barrier certainly provides a benefit as compared to not installing a barrier in the vast majority of cases. This table from the guide simply puts those three categories of hazards into a table form, and allows for easy comparison. If we're dealing with, say, fill batters, you can look to the table and compare the criteria for fill batters and find out which category your particular fill batter falls into. As I mentioned earlier, some lesser hazards certainly may be considered hazardous to motorcyclists and other vulnerable road users. Ken will talk about this more next Tuesday. Some of these hazards that are typical hazards for motorcyclists include our typical steel and timber sign support posts, perhaps our 50mm nominal bore steel posts that we use for most of our standard signs, frangible light poles certainly are not frangible for an errant motorcyclist. Trees of diameter smaller than that 100mm magic number, and so on. And here you can see at a roundabout lots of objects that probably don't present much of a risk to the occupants of an errant vehicle, but would to a motorcyclist. So when we're dealing with motorcyclists, it's important to think about locations at which motorcyclists will typically leave the road, and avoid locating pieces of roadside furniture within those areas, or if we must, to look at using products that are frangible to motorcyclists. And there are some sign support systems available for signs like hazard markers within roundabouts that do provide safe outcomes for motorcyclists.
Amy, we just had a comment come in around, yeah, so you're talking about culverts and some challenges there, but a product or with increased post span ability up to 6 meters, so emitting posts up to 6 meters. So is that around the sort of maximum you've heard of, or is that even?
Yeah, it is. It's generally speaking, it's acceptable to omit one post for any barrier system. So doubling the post spacing for that one span. The 6 meters, I think you're probably referring to a detail that Safe Direction provide for, I think it's the Ram Shield product, where you can achieve a 6 meter clear span if you've got culverts that you need to straddle. So 6 meters is about as high as you would go, but for any barrier system, you can typically achieve 4 meters, not a problem. 4 meters is the rail length for our flexible guard fence products. And similarly for wire rope systems, we can omit one post or increase our post spacing locally to avoid an underground service or whatever it might be. Where we're doing that, we need to be mindful of the fact that the barrier might deflect by a bit more at that location, ensure that there aren't any fixed hazards behind the barrier, and possibly take other steps to stiffen it up, perhaps close up your post spacing either side of that longer span.
Yep, we're getting confirmation on you picked the right product there, Jamie. Yeah, we do in one of the later modules get into some of these design challenges and things that can be done. And Jamie has lots of different examples of a few of those things. So, but they're really good questions about some of those challenges, what you can and can't do with these systems. We do talk generally usually about products. We don't have any alliances with any of the specific suppliers, so we'll just talk generally about products. But if in these cases there's one product that does something different to others, we'll certainly mention that, and that's about knowing your products and what they can do. But that'll be for actually that's pretty much what your assignment is all about, but we'll get to that.
Lateral distance to hazards. I'm sure that all or most of you have heard this term clear zone. Clear zones have been done away with in current guidance. So clear zone thinking or theory is that it's based on some theory that makes sense. The further an object is from the road, the less likely it is to be hit. And in the past, we drew the line at some magical clear zone numbers, beyond which we decided not to treat hazards. In high-speed environments, that number or width was typically 9 meters or perhaps up to 15 meters in a high-speed, high-volume situation. We know that a proportion of errant vehicles in the order of 15% will travel beyond those clear zone widths that we traditionally have adopted. And when we're striving for safe system outcomes, we're just as concerned about those 15% as any other 15%, and we're looking to do better. So it's no longer a defence to say that we've shielded everything within the clear zone or we've treated everything within the clear zone. We need to look to do better. Now, obviously, with limited buckets of money available, we can't sort of do everything, but there are the new Austroads Guide Part 6 provides a new and improved process for assessing roadside risk that's not just based on some static numbers. It takes into account some other risk factors and allows us to prioritise sections of road and compare lengths of road, different roads to each other, and even different lengths within the same road. So clear zones should not be considered as an adequate treatment in their own right. under the safe system, we refer to clear zones as supporting treatments. So you may have heard that term, supporting treatment. Primary treatments are ones that essentially eliminate the risk associated with a particular crash type. And flexible safety barriers are a primary treatment when it comes to run-off road crashes. So that's the level that we're striving to. Supporting treatments are ones that reduce the likelihood of something happening, as a clear zone might. Most vehicles will come to a stop or a cover before they leave that clear area, but a portion of vehicles will not. They'll continue on and strike hazards located beyond, or perhaps roll over. So I encourage you to step past clear zones. This image shows what would have been considered an ideal roadside in the past, with nice clear areas of 9 metres and more, wide, relatively flat median, no trees within cooee of the road. That road presents a reasonably safe environment, but there certainly is potential for vehicles to reach those trees, to reach the opposing carriageway and have head-on crashes, and to roll over within the median. It is the case that vehicles frequently do roll over on what you might perceive to be a nice flat roadside. When a vehicle yaws violently, someone sort of reefs the wheel around in an attempt to recover, it's often the case that is enough to cause the vehicle to flip and roll. It's a very difficult thing to do to ensure that a roadside or a median is maintained with a flat, even and well compacted surface through all seasons. And there have been a number of pieces of research in recent years that have quantified the areas that you might like to provide to achieve safe system outcomes. And they're a hell of a lot greater than the old clear zone numbers that we have adopted. So if we look to a high-speed environment, 100 k's per hour, you would need to provide a very wide, 40 or 50 metre wide area that is flat, well compacted, and so on, to achieve, I guess, an equivalent level of safety to providing a flexible safety barrier much closer to the road. So these type of widths are simply not feasible. You wouldn't look to achieve that. Certainly safety barriers are a much more attractive option. This snip comes from the new Part 6, and it shows in a diagrammatic form the effects of fill batter slopes of different grades. We talked about those slopes of 6:1 or flatter being recoverable. They essentially have no effect on the distance that an errant vehicle will travel from the edge of the road, or very little, certainly. If we steepen that up to greater than 6:1, but not steeper than 4:1, we can expect that vehicle to travel well beyond the toe of that batter and potentially into a tree or another hazard located well beyond the toe of that batter. If that slope is steeper than 4:1, the batter should be considered a hazard in its own right. Now, I do want to introduce you to the risk assessment process that the new Part 6 provides. There are 2 webinars on this topic that I encourage you to look at. They're accessible at the Austroads website. I want to give a brief overview without going into too much detail. So the new risk assessment process, rather than focusing on purely that clear width or the proximity of a hazard to the edge of the road, takes into account a number of things. Uses a typical risk assessment process looking at exposure, likelihood, and severity of crash. And the outcome of the assessment process is to determine what's called a network roadside risk intervention threshold score for a particular section of road. It's a numerical score that you can use to compare the risk of different road lengths, different roads altogether, or perhaps different lengths with different characteristics along the same road. Now, each jurisdiction is currently doing some work to provide some guidance to practitioners about target values for the NRRT. South Australia is leader of the pack there. I think Queensland might not be far behind. Victoria's got some things in the pipeline. But stay tuned for some guidance from your jurisdiction about some target numbers and what that actually means in terms of prioritising your efforts and expenditure.
Now, Jamie, just before you move on there, questions come in and it's associated with that table you displayed a little bit earlier, a few slides back, on the distances that would need to be cleared and well maintained. Yeah, that's the one. And why is it speed limit, not design speed or even operating speed, I suppose?
That's a good question, and I suggest it should be operating speed. That's the operating speed, or the speed that people actually travel, is the speed that we typically look to design to. And it's certainly not always the same as the posted speed limit.
No, that's right. But I actually can give a little bit more. That table is actually out of some research that was done, and that will be the speed zones that they did the investigation of crashes and collected all their data out of. So that will simply be those speed zones where the crashes have come from. That was some work from, that was the MUARC stuff that you referred to earlier, the Monash University Accident Research Centre, also with the Centre for Automotive Safety Research at the University of Adelaide, who are combining their efforts on that one. Good question though, and as Jamie said, better to use that operating speed or design speed. NRRT, certainly something that people should be getting familiar with that terminology. It'll help you in the very short term if you know what NRRT stands for in your quiz, which is coming up at the end of this module. Hint, hint. But it's certainly something that all road authorities are heavily working on at the moment, to a degree, to replace the clear zone theory and thinking that most jurisdictions have been operating under. Okay, back to you, Jamie.
Thanks, Ken. This little flowchart demonstrates the process. The top half is about what's happening at the jurisdiction level, and as I say, stay tuned for that guidance from yours. The bottom half is more at the practitioner level, determining risk scores for sections of road, comparing those against levels set by your jurisdiction, and then thinking about what to do about addressing the risks that are present. So the process, when it comes to hazards, the process distinguishes between background and isolated hazards. Background hazards are those that are consistent and continuous. It might be a batter hinge point at a consistent distance from the edge of the road. It might be a row of trees at much the same offset. It might be the property boundary, particularly if that there's a fence at the boundary that might be hazardous if struck. It's often the case that we have a background hazard, and then we have some more intermittent hazards located in front, which are our isolated hazards. So that might be some trees or poles or other hazardous objects that are located closer to the road than those background hazards. At this roadside, you could probably say that we have a background row of trees nearer to the property boundary. And then we also have a number of isolated trees or intermittent trees sort of closer to the road. So we might have a row of trees at 10 or 15 metres back and then others at 6 metres back. So it's important to think about these different categories of hazards and where they sit in relation to the road when we're going through this process. In an urban environment, our property boundary fence might be our background hazard. In front of that, at a lesser offset, we've got a tree and some poles and more trees and so on. Now, the guide provides a whole heap of tables that look like these. There is a different charts, I should say. There is a different chart for each combination of locality, either rural or urban, terrain type, mountainous, rolling or flat, and also for different operating speeds. And it breaks it up by 70, 90, and 110. So for each combination of those things, we have a different chart to look to. And you need to choose the chart that best represents the conditions that you're dealing with. There might not be one that matches exactly, but choose the one that best represents. It is acceptable to interpolate between lines if and when you need to. So these charts you'll see relate to undivided rural roads with significant background hazards. And if we picked an example, as an example, we had a road in a 110 kilometre per hour environment, or that was our operating speed, we'd be looking at this chart here. It's a rolling terrain. If our AADT, annual average daily traffic, was in the order of 3,000 vehicles per day, and we had hazards like located at 9 metres typically, background hazard at 9 metres, we could read across to our vertical axis and work out that our risk score is in the order of 2.7 or something like that. You can use the same process to assess different lengths along the same road that might have differing traffic volumes, differing hazard offsets, differing operating speeds, terrain types, and so on, and come up with a score for each of those different sections.
Jamie, that answers one of the questions that just came in about how to work out the risk on, where do you find the information about the risk of features of the roadside. So it's the Austroads Guide to Road Design Part 6, the new one, the 2020 version that's come out, and you're using these tables which give you an indication of the risk, but this gives this risk score. So what you can use that for is comparing risks of different hazards that are currently there, but the choice on whether or not barrier system is required relies on that NRRIT score, which needs to be set by the road manager or the road authority there. So it gives you a couple of really great tools to be able to say, well, that tree is more risky than that culvert on, down that slope, or those sorts of answers. But do either of those need a barrier? Well, you really need that NRRIT score to make that call, which, as Jamie says, only South Australia has actually released any of those yet, and they sort of are something. But I think you would go about considering upgrades to a roadside based on the budget you've got to be able to expend, and then trying to address as many of the highest risk locations as possible.
Some more similar charts from the guide. In this case, we're looking at divided urban roads, and you can see immediately that the risk score numbers that we're dealing with are lower, and that's primarily due to the reduced speeds that we're dealing with. So that there is something in the order of 30, I think, charts for all the different combinations of situations that you might encounter on the network. Right, so we've assessed our roadside risk, and now we need to think about what to do about it. The guide lists these different treatment options. It previously provided a hierarchy, a treatment hierarchy, and the preference was to look to eliminate hazards or remove hazards before treating them with safety barriers. That is certainly no longer the case. And I don't think it's any coincidence that safety barriers appear at the top of the list. So installing safety barriers to shield roadside objects is our primary safe system treatment. There are other things that we can do to support safety barriers or to reduce the likelihood of people departing the road and striking roadside objects, like improving delineation and so on. If we remove the hazard, it's doing something, but it's not eliminating all risk because there remains that rollover risk, the potential for vehicles to travel well beyond the distances that we previously assumed for clear zones. And it is usually the case that a combination of these things is the best treatment. So look, installing barriers really is number one. Some quotes there from the guide that really back that up. And look, the current thinking, the products that we have available really is that flexible safety barriers subject to the constraints of the site and are the go-to treatment. And that continuous barriers really do have merit on our high volume, high speed roads in particular. That said, we must consider the potential risks presented by barriers, especially where they're not maintained in an adequate way, or if they're not designed in the best way. It is the terminals of barrier treatments that present the greatest risk, and some of the now superseded terminals are the prime candidates and can result in spearing type incidents, as you can see here. So the old breakaway cable treatments, things like melts and so on that are now legacy products in different jurisdictions. Certainly we should see no more installations of those, and they should be progressively upgraded on the network to the new and improved breed of products. Another instance where a breakaway cable terminal was struck. Fortunately, on this occasion, it didn't spear into the vehicle. It was fortunate that the vehicle was contained without entering the roadside, but that easily could not have been the case. Another disadvantage of these type of products is that they're entirely gating, meaning that their entire length is ineffective in redirecting an errant vehicle. The intention of these older systems was to allow the vehicle to pass through the terminal and into the roadside, whereas the newer products are largely redirective. A vehicle that strikes them side on will be redirected, and the vehicle that strikes them end on will be brought to a controlled stop.
And Jamie, before you jump onto the next slide, I think the next slide we might do is a little interactive exercise. So when you put up the picture, we'll see if people can type in anything they might see as deficiencies or safety issues with the barrier system that's there, and we might give out a couple of prizes. So that was one thing I wanted to say. Oh, the second one was just to those who are a little bit new to some of the terminology Jamie's using, we have provided a terminology sheet for you. I believe it's on your memory stick and in Schoology. I'll double check that in a second. Sorry, not in Schoology, in Moodle. That's the new system we're using. And it just goes through lots of these terms and makes sure that you're on the same page. So, you know, if you, it keeps talking about a hinge point, I don't know what that is. Well, you can look up that in that sheet, or of course you can just Google it, which is pretty good as well. But let's do this little interactive exercise for the next one. So get your typing fingers ready, get the chat box open, and Jamie, pop that up, and any issues that people see, and we'll give out a few prizes. Oh, it's pretty good to me. Nice shiny new barrier system. Okay, it's coming in. Oh gee, I'm loving this. My challenge is keeping up here. Okay, Callum in there with one. So Fishtail, a terminal, and Naomi in second with poles not behind the barrier. It's sort of in the middle of the barrier there, isn't it? And then an absolute flood of answers came in after that, which are all very good stuff, and you're all picking the same things. I'm just scanning through to see if anybody else had anything different. Callum also put in there a bit about the footpath potentially being in deflection zones. Good thing potentially to look at. And nobody mentioned the sort of proximity of the curb to barrier, which is an interesting one as well. But there you go, Jamie. And Catherine's even adding no rub rail. So thinking of other road users, not just cars, thinking of the motorcyclists, and we'll talk about that one next time. But hang on a second. So it was Callum and Naomi. Good. All right. The others, just maybe it was all about internet speed, really. All the answers came flooding in. Very good, though. Back to you, Jamie.
I think Doug deserves a prize too, because he's picked up something that I hadn't actually noticed before. He's identified that the lapping of the rail is wrong, and as I look closely, I can see it now.
Doug, well done. That's excellent. Prize coming to Doug. We're going to run out of prizes, Jamie. This is excellent. I love a group where I run out of prizes.
So this is more along the lines of things that we'll be talking about in later sessions, but the general preference is to overlap rails with the direction of travel in the closest traffic lane. So the first rail would be on top of the next rail, which would be on top of the next one. You can see at the joints here, the overlap is in the reverse direction to what it should be. Well done. Yeah, so some few obvious things going on there, and I believe this barrier was installed more as a device to funnel pedestrians and prevent pedestrians from crossing at this location rather than any other road safety reason.
So some good, yeah, really great stuff in there. The question has come in about, well, where would you put it? How would you alter this to make it safer, and also, you know, what sort of terminals and those sorts of things? Do you want to briefly do that? I think you've got time to
yeah, look, an alternative would be to locate it at the very back of curb, and because it is a barrier curb, the preference would be to locate the rail of that barrier sort of in line with the curb.
Just run your cursor on that. I can't.
So if we had brought our barrier forward so that the rail was located in line with the face of that curb, we'd be taking out any potential effects of vehicles striking that curb and bouncing up, as tends to happen. The bumper trajectory changes, and the vehicle can strike barriers at heights that we wouldn't expect or like, which can reduce their performance. So it's typically the case with barrier curbs that we wouldn't want to install a barrier behind because of that reason. we could perhaps locate the barrier just in front of the pole. It wouldn't have the deflection space that it would need, but it would offer some protection. And we could do things to stiffen it up and reduce its deflection. You would like to see an accepted terminal type as opposed to this fishtail, which may spear into an impacting vehicle. And also the system's not anchored to the ground. All of the currently accepted terminal types anchor to the ground. And a lot of the strength in these systems is developed through that anchor and the tension that's developed in the barrier. So yeah, there's a few things there that could have been done differently.
Yeah, and Catherine's pointed out that would it be possible to extend that to try and cover the curve and some of those other poles as well? So it's a bit of a random spot for it, but anyway, there you go. Thank you, everybody.
So, as I say, the terminals really are the most dangerous part of the barrier system. They are all accepted. They've been crash tested. In theory, they provide safe outcomes when struck end on. But we're talking about bringing a vehicle that's travelling at 100 kilometres per hour or more to a stop over a distance of 15 metres. It's still not going to tickle. Strikes with barriers can result in vehicles ending up on opposing carriageways or blocking carriageways, fuel spills, and all sorts of other things that can have some other consequences. So minimising the likelihood of terminals being struck and choosing our terminal products wisely is important when it comes to barrier design. In the picture you can see here, we have a particularly narrow flush median with a back-to-back guard fence in it. The terminal there is really quite wide, and there's very minimal clearance either side of that terminal. On this particular road, there have been a lot of terminal strikes, and this particular terminal was struck very soon after opening by the Coles truck. There have been a lot of subsequent strikes with different median terminals along this length of road, and trucks certainly are overrepresented in those strikes for a number of reasons, but primarily because trucks, develop more sway than other vehicles and require a greater width of road. So there really have been some learnings and some improvements in guidance around locating terminals in narrow medians in recent years. Victoria has some road design notes which are available at the VicRoads website. And the preference these days is to provide a wider median than the 1.4 metre median that was installed here and at other locations to locally widen the median. And if possible, install a raised island with some signs and extra delineation in advance of those terminals. Another location was struck. In this case, we had a wire rope terminal, a newly installed wire rope down the median. The road was yet to be restored to its proper speed limit. It was still under traffic management. And this terminal and a fair length of barrier was taken out, presumably again by a truck. So as a result of some of the learnings in recent years, or certainly the Austroads guides have taken on board some of these learnings. The different states provide their own specific guidance. Victoria has some good stuff, and you can see a couple of its road design notes pictured there. One around central barrier in narrow medians. That includes some guidance around terminal treatments in medians and increasing the width around those terminals. On the right, we have the road design note around continuous barrier treatments for high-speed roads. That deals with all things from barrier selection, lateral offset, dealing with constraints, providing refuge bays, all sorts of things that need to be considered where we're looking to install continuous barriers. Each jurisdiction does have some differences in how it goes about these things. The Austroads Guide covers off on some of these things, but really is more of a high level piece of guidance. And there is a lot of decision making still to be made at the practitioner level. In Victoria, a lot of that sort of thinking has been sort of rationalised into these road design notes. But I do want to stress again that the terminals really are the most hazardous part of a barrier system. Locating them and minimising the number of terminals is important. Certainly, you should look to provide a single longer length of barrier as opposed to a number of short successive barriers. With additional terminals, which are potentially hazardous, you might find that that single long length is actually even a cheaper solution because the terminals are more expensive, significantly more expensive than the equivalent length of longitudinal barrier. That's all I have, Ken. Very happy to take any questions that are coming through.
Good, thanks, Jamie. And we'll give people an opportunity now to pop in any questions they may have. I suppose I'll kick one off, which is something that bubbles around quite a bit. It's associated with this idea that remove the hazard is no longer the number one thing to do. And that sort of flies in the face of the hierarchy of control, really, doesn't it? If you think about it that way. Did you want to make some comment on that?
Yeah, yes. So there's removing the hazard and there's removing all hazards. We can remove a tree or a pole or the like and eliminate the risk associated with that particular feature, but there will always remain some inherent risk in a roadside. It might be other rigid objects located further away from the road. It might be that rollover crash risk. So yeah, we really are going away from that. I suppose you could put removing all hazards at the same level as installing a barrier, but to remove all hazards would be to provide a very wide, clear, flat area in the order of 40 or 50 metres in a high-speed environment, which is just not a feasible outcome.
Yeah, okay. That's it sort of links, I suppose, with the next thing I just wanted to touch on was this the idea that clear zone theory is not accepted anymore, I suppose, which is something that's been around certainly my whole career, and it's been around much longer than that. It's a pretty big shift for the industry. What was I suppose, what was driving that, and is what we've got better or easier or clearer, or is it going to give us better outcomes?
Look, clear zone thinking really originated in the States in the 60s, and it was based on measurements of vehicles leaving tracks in snow, as I understand it. So if you think about the vehicle fleet, that was based on the conditions that research was based on, it certainly doesn't equate to what we encounter here. So its applicability is questionable. We do know that 15 or 20% of vehicles travel well beyond those clear zones. So it really just doesn't stack up under safe system thinking these days. The new approach, is it easier to apply? Certainly it's going to take some getting used to. It does take into account a number of other risk factors. It's more of a multi-pronged look at things than purely lateral offset to hazard. So I think from that point of view, it's an improved tool. It does provide for better comparison between different lengths of road. So, yeah.
I suppose one thing I'll just add to that, I think, is potentially a bit of the misuse of clear zone theory to a degree, and I do caution people in the use of the NRRIT and this new risk scoring methodology in the Austroads Guide to Road Design Part 6, where you find this risk score, and to a degree, there was a time where with clear zone, people had this, if you have sort of offset here, distance, and you're starting at, edge line there, that if your clear zone was 9 meters, for example, and this was risk, that it was sort of went like this, down to 0, magically at 9 meters. Where, I think everybody, common sense wise, knew, and that sort of, risk would do that, and maybe wouldn't actually get to 0. It'd sort of asymptote out as it continued out. But the operation was that this somehow magical at an 8.9, high risk, point source hazard. At 9.1, it's outside the clear zone, don't worry about it. And that thinking was really, you had to draw the line somewhere, but that clear cut that apparently there's no risk. And we saw that play out with new roads and rigid structures and poles just being 9 meters and just lining at 9 meters throughout a roadway. So this certainly helps out. But even with this, you've got to recognize that they don't magically disappear in risk. It's just lessened, and the risk will remain. So I thought I'd just add that. I think it might help a few people get their head around a few of these things. Now, how do I stop sharing? There we go. What do we got? We got another questions come in, I think. Are end terminals required on all barrier types? Amy?
Every barrier needs an end treatment of some type. Any guard fence barrier needs, or wire rope needs an end terminal. I suppose in the case of guard fence, you can transition to a rigid barrier, which is, I suppose, your end treatment of sorts. Rigid systems need an end treatment, so that might be a crash cushion rather than an end terminal as such, but any barrier needs to be terminated with an end treatment that can be safely struck end on, if there is that possibility that a vehicle can strike it end on.
Yeah, and Evan Coulson on Thursday is going to talk you through the process of choosing those and which ones are accepted, and some different alternative options. Another question here: is there a role for cushioning trees, so large shrubs, bushes, etc.? I assume that means in the roadside to act as a buffer and slow vehicles down. You want me to take this one, Jamie? Because I about 15 years ago commissioned a research report into vegetation as roadside countermeasures, and there was potential with some species that it had the ability, or it had the characteristics that it could do that. It was more the practical implementation of that was such a massive challenge, where you put this out on a roadside. Well, you'd need to be sure that you were keeping that species only, so it need to be maintained. If vehicles did roll off into it, how do you sort of re-get that back? What do you're replanting and those sorts of challenges. So it was more the practical implementation of it. In theory, that you could provide 5, 7, 10 meters of of a specific product, which would be pretty good for passenger vehicles, slow them down, kind of like your sand trap in a racetrack. The theory behind it will work, but when we got into really practical application of it, we couldn't determine anything that would really help us out there. But the idea is nice, and you know, potentially something to look a bit more at. So one more question. Do you see a point in time where BCTA, breakaway cable terminal A, are completely upgraded by all road authorities, so we get rid of them all, because they're currently out there on quite a bit of the network with a breakaway cable terminal? Comments on that, Jamie, just before we start to...
Yeah, at this point in time, those systems are typically replaced if they are struck or sort of, you know, become inoperable. As for a mass action sort of rollout, look, it might happen, and that'd be nice. You're probably opening up some cans of worms because they're typically installed on older barriers. The heights of new systems have increased. You know, the question then would be asked: do you just retrofit the terminal? Do you look at the entire barrier? You know, it would probably only take a fatal crash involving a BCTA for you know, for this to jump up the list of priorities. You know, there has been talk of mass rollouts of upgrades. It's not a cheap thing to do. The newer systems are, you know, perhaps $4 or $5 grand each, something like that.
Yeah. So just, I suppose, to add to that, when you are doing road upgrades, it is important to look at those, though. They're often in quite high-risk locations, some of those existing systems, because they were put in, you know, back in the day when it was identified as the highest risk spot, and so you have these sort of poor barriers with not great end terminals in pretty high-risk spots. So when you can upgrade them, do, but it'll be a while before they're all rolled out. Now, website has products available. Queensland has the same, I understand, and South Australia has the same. So every jurisdiction, and it's the road authority which is sort of providing that list. So you just need to go and find that. But if you really need it before Thursday, let me know, and I can provide a link to it, or you can find it. But Evan will take you through that in very specific detail about what is on that, how do they get on that list, what are the products available, what are some of their characteristics, when would you choose them, and the like, how do they function, what sort of weight of vehicle are they tested to, and Jamie referred to test levels. You know, that's the weight of the vehicle and the speed and the crash angles that it's been tested and proven to withstand. So Evan's going to take you through all of that on Thursday. So unless there's any other questions, I'll wrap up with a couple of things. First of all, you do now have a quiz to do in Moodle, and we would love you to do that before the start of next session. But if you don't get around to it, really your requirement is to make sure you've done all of those quizzes before the end of the course. You don't have an assignment as such after today. You'll have that after Evan's presentation, where you will be actually required to use those road design notes or those pages on your road authority's website to find a product that we assign to you. And for Thursday, if you arrive a little bit early, probably 3 minutes or 4 minutes before the start, 3 minutes before the start, we'll ask a few trivia questions. Could be general knowledge, could be barrier trivia, but we'll give out a few prizes even before things kick off. The reason I want to do that is I want to make sure you're settled, you're comfortable, because Evan's got a huge amount of information that he wants to try to provide in the time, and we're going to hit the ground running straight on 2 o'clock on Thursday. So look forward to seeing you there. Thank you for your input. We've got a big list of prize winners already. Hopefully we'll add to that a couple of minutes before on Thursday. Thanks, Jamie, and thank you all for your participation.